Now let's look at the Riemann sum. Last time we talked about when we have a function, this is the x-axis, we have a function, right? This is the y equals f of x. We want to find the area, right? The area of the region between the function curve and the x-axis, right? What we should do, we make some intervals, right? Divide our AB interval into several subintervals. Then we make some rectangle on each subinterval. Okay. So we divide our interval AB into n subintervals. With equal lengths, which is denoted by delta x, which is given by b minus a divided by n, right? So the ith interval is actually what is the xi minus 1 to xi. Okay, so this is our AB, A, and B. Right, this is x naught, this is x1, x2, x3, and continue. This is xi minus 1, this is xi. And continue, and here is xn minus 1. This is xn. Okay. Then on each subinterval, we pick an arbitrary point. We pick Ci. We pick to be any point in the interval xi minus 1 to xi. So here is Ci. This is the C3. Here is C2. Right, this is C1. We used f values as its height of the rectangle. Then we do the calculation. We compute the area for the rectangles. So which would be the f, the height, times the base. The base is the length of the subintervals, right? Then we add them up. I from 1 to n. And it will be an approximation to the area, right? So this sum is called the Riemann sum. With equal lengths. Okay, actually, we don't need any equal lengths. Okay, so this is A, this is B. We can put this one x1, this is x0. Here is x2. And here is x3, for example, and here is xi minus 1, and here is xi, and continue. This is the xn minus 1, this is the xn. Okay. So the length of the ith interval is denoted by delta x sub I. Okay, So we still pick arbitrary point on each interval C1, C2, and this is C2, this is C3, this is CI, right? And then we can compute the area for the ith rectangle. Then sum up I from, oh sorry, this is not infinity. We sum up all the rectangles. It would be also an approximation, right? So this sum is called the general Riemann sum. Okay. But for many cases, we always use this one. The reason is this is much easier to deal with because this number is a constant.